Okay guys, so moving on to section 4.3 now. Last time we kind of beat up everything we can do with linear functions, at least for now, and now we're going to go ahead and move on to quadratic functions. So that x squared thing, like a kind of versions of the square function. Okay, so let's take a look and see what's going on here. So the first thing I want to look at is let's draw a parabola on here real fast. So let's get one. I'm going to purposely kind of off-center it a little bit, so let's put it like right about here. Alright, so there's our parabola. So let's take a look at some of the pieces, the sections of the parabola. So remember, this is called a parabola. So it's a parabola, and it's a version of the square function. Remember, a quadratic function, so f of x equals x squared. It's all kind of variations of that f of x equals x squared. One of the spots right here, kind of an important point. We didn't really give it a name before. That was the point that used to be at the origin at 0, 0, and then we kind of moved it around as we did our translations or transformations. And so we have a name for this point now. It's called the vertex. So this is called the vertex. And similarly to how we named like the center of a circle, we're going to call the vertex the same way. It's a point, so it's an xy, but we're going to use the letters hk. So hk are going to be the x and the y coordinate for this point that is the vertex. Okay. Also, something about a parabola is it's symmetrical, like left and right. You could fold it in half. If you wanted to, it should be exactly the same on both sides. And there's a line that you could fold it on, and that line is actually, it goes right through here. Actually goes right through the vertex. It's a vertical line that goes right through the vertex. That line is called the axis of symmetry. It's called the axis of symmetry. And if you remember, the equation for a vertical line is x equals. So it's x equals some number. X equals some number. Now the thing is, though, it goes through the vertex. So the x equals some number, it's going to be the same number as the x value of the vertex, because it has to go through the vertex. So it goes through all the points, x something. So it's going to be x. And the number we're going to use is the x value of the vertex. So h, whatever that number is, h, that is the equation for the axis of symmetry, is x equals some number, the number being the x value of the vertex. Okay. All right. What else do we know about this? It has this point right here. That's the point where the graph crosses the y-axis, and we know the name of that. That's the y-intercept. Y-intercept. And remember, the y-intercept is when x equals 0. So when x equals 0. Another way to write that is we can say that's f of 0. We plug in 0 to the function. So a 0 goes in, and what comes out, whatever comes out. And that's also a point, and it can be written as the point 0. It's always 0 because x is 0. Something. 0 something. 0 some number. Don't know what it is, but it could be down here, it could be up here, whatever it is. But so there we go. So that's our y-intercept, is right there, the point where we cross the y-axis. Last thing we got to look at are these points right here. We should remember these are the x-intercepts. So these are the x-intercepts. And these are the points where where f of x, some x value goes in and a 0 comes out. We saw that on the last test where where some number goes in, so we go over some amount and then we don't go up and down any. So we end up exactly on the x-axis. So f of x equals 0. That's when our x-intercepts happen. And again, there are 2 points, and those points, whatever they are, they would look like some number goes some number over and then 0. Because the y value is 0 for that point. Okay, so that's all the stuff that we kind of know about the parabola. Something else we got to look at is this point right here, the vertex. This parabola happens to be opening up. This is that's the way I say that. Is it opens up as we go, kind of. If you start from the vertex and kind of go out in both directions, these lines kind of keep going up. They're increasing, kind of all over the place. And so when it opens up, the vertex, notice, is like the lowest point on the parabola. If the parabola opens up, the vertex is the lowest point. I set it down here. If the parabola opens up, the vertex is the lowest point, so it's a minimum. The vertex is a minimum if the parabola opens up. If the parabola opens down, so it's flipped over, then the vertex is the highest point, and so that would make the vertex a maximum, because it would look, it would look something like this. And that's the vertex. So it would be like the tallest point of the curve. So that's why if it opens down, then the vertex becomes a maximum. Right. Last little thing here. We've ran into a couple different ways to write the equation for a quadratic, and we had this form right here: ax squared plus bx plus c. That's the one when we were when we were solving quadratic equations using the quadratic formula. There's our a, b, and c that we were using, doing our completing the square, all that kind of stuff. We used it from this form of it. It's called standard form. Now the one we've been using recently when we use our transformations is this one, vertex form, where we kind of go over, the number inside makes it go left or right, the number outside here makes it go up or down, and the number out front makes it either stretched or compressed. And so this is a different form. This one's very nice when it comes to graphing. If we could have it in this form, it'd be nice to graph. And the reason why we call it vertex form is because of this. If we come down here, here's so like f of x equals x squared. Remember, this one looks like this. Yeah, that's the the parent function of the square function. If we come over here, I've done this now. So if you remember our transformations, it's minus 5 inside, so it goes to the right 5. 1, 2, 3, 4, 5, and then it's a plus 3 out front, so it goes up 3. 1, 2, 3. Or out to the side, sorry. So now that's our vertex now. That's where that point goes. And then it's still positive, so it goes up. That should totally have gone through the vertex right there. Okay, so there we go. Now if we look, what's this point right here? The vertex now, what is this point? Well, it went over 5 and up 3. This is the point 5, 3. That's the vertex. And if you notice, there's our 5, and there's our 3. In the vertex, there's so the x value is this minus 5. So it was a minus 5 in here, and ended up being a plus 5 when we came to writing the vertex down. Remember, because it went the other direction. And then it was a 3 here. The point was a 3, and we ended up getting this plus 3 over here. If this was a minus 3, then it would be a negative 3. Up here. But so that's why we call it vertex form, because if we just had this equation right here, we could look at it and say, where's the vertex of this? Oh, okay, here it is. It's at the point 5, 3. Remember, we take the opposite of this one. So there was a minus 5, we do 5. So the vertex, just by looking at this equation, we can say 5, 3, and we're done. And that's it. And so now we have the vertex. We know that it opens up because it's positive out here. We know it hasn't been stretched or compressed. So very quickly, if we have this, we know where the vertex is, and then we can graph it real fast. That's the kind of advantage of using vertex form. And I think, well, we'll stop there, because now we're going to actually kind of look and see how we can manipulate things to be better off for us. Okay, so I'll see you in a second.